Hey everybody, it's Mr. Carr again. Today we're going to be talking about 4-6 day 1. And in this sense, in this part of the unit, we're going to be talking about inverses of so in the previous units, you've talked about inverses of relations. So today we're going to be talking about our inverse trigonometric functions. Okay. That's just going to be day 1, and we'll talk about compositions of our trigonometric functions on the next lesson. So what do we mean when we talk about an inverse? So this is our rough idea of what an inverse function is for each of these. So I want to actually pull this up real fast down here too. As you can see, this are our normal sine, cosine, and tangent functions. So if I were to continue on, and I probably should have done one more like this, if you check the whole function, none of the functions are one-to-one. Remember what that means is it does not pass the horizontal line test when we draw those in, okay? So what that means is that inverses do not exist for the entire function. Instead, we talk about it as long as we restrict the domain. So in case of sine, we're going to look at it between negative pi over 2 and pi over 2, because if I take my sine function, I go negative pi over 2 this way, this is going to take me here, and this is pi over 2. So what I'm really doing is I am just ignoring all of this and focusing just on this section. This part of the sine curve does have an inverse. It is one-to-one. If I go through and check that, it passes the horizontal line test. Same idea with cosine. If I cut it off here and get rid of all of this and just focus on this section, that also has an inverse. And then with tangent, if I just focus on one of these cycles here, one complete period, this right here has an inverse. So I'm ignoring all this other parts of the original sine, cosine, and tangent functions and just focusing on what does have an inverse if I restrict the domain. So that's why I get some of these characteristics. So for sine, or I should say inverse sine, okay, the inverse of sine, we're going to get a domain of -1 to 1. Okay, so that is because it goes down here and up here. That's the only parts that the normal sine function exists. That's the range of that sine function. So that's going to be in my domain. The range is going to be pi over 2 and negative pi over 2 to pi over 2, which is saying here to here for my domain. So if I just focus on that one section of the sine curve, that does have an inverse. So then this is what the inverse function will look like. So again, this is the inverse of this section of the curve. This is the inverse of this section of the curve. This is an inverse of that curve, okay? So again, domain in both inverse sine and inverse cosine is going to be -1 to 1. And then inverse tangent, if you look at that one, actually has no limit. The reason why is when I look at the range here, this is going to go down forever and this is going to go up forever. So every possible value in the range is going to be in the domain of my inverse, okay? But the domain here is restricted because it's got to be negative pi over 2 to pi over 2. So that means my range could only go up to pi over 2 and down to a negative pi over 2. So this is going to help us when we're going to evaluate these to find exact values. So find the exact value of the the inverse sine of √2/2, if it exists. The first key on this one is checking if it exists. Since we're dealing with sine, the domain needs to be -1 to 1. So we're going to double check. What is the square root of 2/2? So I'm going to put that in my calculator just to get an approximate decimal number here. And that comes out to 0.707. So that does fall into this domain. So that means I can evaluate this. Now, when I do this, I like to set them up. I draw it up kind of on a unit circle just to get a feel for what this looks like. Sine is opposite over hypotenuse. So I'm going to go ahead and draw my reference triangle. And I'm going to draw it in the first quadrant because this is a positive √2/2. Okay, remember, this is where all students take calculus. These are all the positive ones. So since I'm dealing with a positive sign, I'm going to put it in the first quadrant. If it was a negative sign, because my range has to be that was negative pi over 2. Yeah. My range is going to be negative pi over 2 to pi over 2. Okay. That would put me in these two quadrants right here. So sine is only going to be, when I evaluate this, I'm only going to evaluate it in one of these two. I don't even care about that. Okay, so in this case, because it's a positive sign, it's going to be in the first quadrant. My opposite side, here's my theta here. Opposite is going to be root 2. Hypotenuse is 2. So the goal here is to find what is theta. So theta has to create root 2 and 2 like that. So based on what I know about these, I'm going to use my reference triangles. So I think it's going to kind of be related to a 45, 45, 90, which is going to be x root 2. Okay, because if I look at that, if I go from here to here, I'm dividing by root 2. So if I take, for example, in this case, 2 divided by root 2, and then I rationalize that, so I multiply it by root 2 and root 2, that's going to be the same as 2 root 2 over 2, which is equal to root 2. So that means this triangle is 45, 45, 90 triangle. So now that I know that, again, using those reference triangles, I know what theta has to be. Theta is equal to pi over 4 or 45 degrees. I'm going to do that in degrees instead of radians. Okay. So again, that's what we're going to use our reference triangles. We're going to map it out on a unit circle. That's what's going to help us find that exact value of our inverse. Let's do the same thing here. Inverse sine of negative 2 pi if it exists. So we're going to double check what is negative 2 pi going to be. Well, negative 2 pi is going to put me outside of my range. So negative 2 pi, okay. Sorry, get rid of that. So negative 2 pi is equal to, if I do that real quick, comes out to negative 6.283. So that means that this does not exist. I am not going to be able to evaluate the inverse sine of negative 2 pi. Okay. Exact value of arc sine of negative root 3 over 2. So again, I'm going to just do this double check. Does this fall in my domain of negative 1 to 1? So negative root 3 over 2 is going to be approximately equal to by 2 there, negative 0.867. So that does work. Oh, I'm sorry, 866. Okay, negative 0.866. So that does fall into this domain. So I'm going to now draw out my sine function. Remember, it's opposite over hypotenuse. It's going to be negative in this fourth quadrant. So I'm going to put it down here. Okay, right there in that spot. So opposite is root 3, and then hypotenuse is 2. So if, again, you look at this, you're looking at your reference triangles. I'm creating a 30, 60, 90. And I should have drawn that triangle better, but my 30, 60, 90 looks like this. It's going to be 30, 60, 90 is 1, 2, and root 3. My hypotenuse is 2. My one side is root 3. Root 3 is across the 60 degrees. So this is going to be 60 degrees right here. So in this scenario, because remember, domain is going to be negative pi over 2 to pi over 2. Whoops. That's, or not domain, sorry. That's going to be range. The range of my inverse is negative pi over 2 to pi over 2. I am not going to describe this angle as going all the way around here and seeing what position it's in here. I'm going to go from here to here in the negative direction. So technically, if I look at this, my theta here is equal to a negative 60 degrees. Or, because I'm dealing with this, if I deal with radians, it's going to be a negative pi over 3. That negative pi over 3 is in the range of negative pi over 2 to pi over 2. Okay? So, that's our sines. Let's now talk about cosine. Okay, so cosine, inverse cosine of negative 1. So domain of cosine for inverses is, again, negative 1 to 1. So this does pass. It's okay. We're going to find this one here. When we do the cosine one, that range is a little bit different. That range is going from 0 to pi. Okay, let me jump up here real fast. That is right here. Okay, 0 up to pi right here. Okay, again, that's 0 to pi in my domain of the original cosine. So my inverse is, that's the range. So that means right here, 0 to pi is only going to be these two quadrants right here. That's going to be my focus. Now, this one's a little bit trickier because cosine is equal to 1. So what I have to remember here is that's going to create a quadrantal angle. So it's either here, here, here. Okay. So this is the point 1, 0. This is 0, 1. And then this is negative 1, 0. What helps with this is understanding which of these points creates cosine. Cosine is the x value. So since cosine of theta is 1 there, the inverse cosine of 1 is equal to 0, either 0 radians or 0 degrees. Doesn't really matter in this case. Okay, so it's this angle right here at that 0 mark, that quadrantal angle. If it was inverse cosine of 0, for example, that would be at this position. So inverse cosine of 0 would actually be pi over 2, because that's the position right here. Okay, so that's what would fall under that one. So that's our quadrantal angles that give a little bit of a trickiness to it. Arc cosine of negative root 3 over 2. So don't forget, arc cosine is the same thing as saying inverse cosine. Again, just like before, we know that this is going to fall in the domain of negative 1 to 1, so we're good there. So I'm going to go ahead and map this out. Cosine is negative. That puts me in my second quadrant. So I'm going to draw it here, and this is now going to be adjacent to hypotenuse. So I'm going to draw it kind of like this. I got right there and right there. The adjacent is going to be, no, not quite like that. Sorry, draw them all like this. Root 3 and 2, whoops, and 2 here. So that's my negative root 3, and that's my 2 for my hypotenuse. To find this out right here, this is my theta here. So, well, sorry, that's my reference angle, is that one. This is going to be my theta, is going from there to there. So I need to figure out what is my reference angle here to help me find that theta value. In this case, because again, I'm using my 30, 60, 90s. If I draw it out real quick, I got 30, 60, 90. So 1, 2, and root 3. Again, root 3 is across the 60 degrees. So root 3 here is across 60, making this 30 degrees. Or if I put it in radians, it's pi over 6 for my reference angle for that. So the actual position that creates an arc cosine of negative root 3 over 2 is going to be the rest of this angle here, which is going to be pi minus pi over 6, meaning that the arc cosine, oops, I have those two, of negative root 3 over 2 is equal to 5 pi over 6. That's getting this right here, pi minus pi over 6. Okay, and I believe this is going to be, oh, no, not quite the last one. Exact value of cosine, inverse cosine of negative 2, if it exists. Negative 2 is outside the range, so this one does not exist. So we're going to move on from that one. Okay. Find the exact value of arctan of 1, if it exists. So now in this case, it will exist. My domain here is negative infinity to infinity. So I can evaluate the arctan of any or inverse tan or arctan of any number I want. So that being said, I do need to be aware of what is happening here. Tangent is going to be, because tangent is opposite over adjacent, that ratio gives me 1 or 1 over 1. So again, thinking about my reference triangles, if I draw this out, I need to figure out when is the opposite side the same as the adjacent side. The other thing of this too, since our range, some back from before, our range is negative pi over 2 to pi over 2. That again tells me I'm going to only deal with these first two, these quadrants, the first and the fourth. So where I get the opposite and adjacent side going to be the same is if I draw my triangle out like this. Okay. And in this case, for it to be 1, it'll actually be, I can do it as 1, 1, and root 2. So that's how I can do it this way. So 1 over 1 is just 1. Or if I'm doing the unit circle, this point on the unit circle is root 2 over 2, root 2 over 2. It works the same way with my tangent then. Again, recognizing what that is, that's a 45, 45, 90 triangle. So that means my theta here, arc tan of 1 is going to come out as pi over 4, or 45 degrees. Okay. And then I have one more to cover in this one. So one more inverse tangent. So that's root 3 over 3 if this exists. Again, root 3 over 3 is in between negative infinity and infinity. So that exists. So we're going to map this out. There we go. This is going to be opposite and adjacent. Since it's a positive, it's going to go in the first quadrant. So the opposite side is root 3. Okay. Just draw my triangle here. Opposite is root 3, and then this side is 3. So from there, again, thinking about how my reference triangle kind of works, can be a little bit tricky when we're dealing with this. Okay. If this is 30, 60, we got 1, 2, whoops, 2, root 3. What I like to focus on is the fact that this side here, if I go from here to here, it's multiplied by root 3. Okay. So that's actually the same thing as if I go from here to here. If I multiply that by root 3, I get this 3 down here. So that's in the same order. So that makes this 60 and this is 30 degrees. Okay. I'm looking at that pattern of my special right triangle. That's going to help me figure this out. So that means 30 degrees is my reference angle there. So the inverse tangent of root 3 over 3 is equal to 30 degrees, or pi over 6 radians. Okay. And that is it. So again, the goal with this today is understanding where does the inverse exist. For sine and cosine, it only exists from -1 to 1. For tangent, it's any number you want. After you figure that part out, so you figure out that it does exist, we can map it out using our opposite and adjacents to help us find those values. Good timing for that bell on that one. Okay. And that's it for today. So take care, everyone, on this one.